Today we'll be looking at trigonometry. We're looking at trigonometry. So you need to understand what the concept of trigonometry is. So what is trigonometry, and then how do we deal with that? So at the end of this lesson, you should be able to understand the concept and terminologies used in trigonometry. The concept and terminologies using trigonometry. You should be able to understand those concepts. All right. So there are some terms, there are some languages we use there. We must be able to understand what we mean when we saying those words. So also at the end of today's lesson, you should be able to apply the theorem Pythagoras, and at the end of the lesson, you should be able to define all the trigonometric ratios. All right, you're able to define the trigonometric ratios. Okay, so now, first of all, the word trigonometry is gotten from a Greek word which implies from the word trees, which means tree, and gonia, which means angle, and metron, which implies what? Measure. So basically, we're saying trigonometry is the study of what? Three angles, basically triangles. So in trigonometry, we talk about triangles. We talk about we learn about triangles. So trigonometry basically has to do with the study of triangles, the study and the measurement of triangles, right? So now, but what type of triangle do we talk about? So in trigonometry, we talk specifically on right angle. As we did understand that before now, we have different types of triangle. We have the triangle, we have the equilateral triangle, we have the scaling triangle, we have the right angle triangle. So we're saying in trigonometry, we strictly dealing with a right angle triangle. Okay, right. So some of those things we talk about in trigonometry, we talk about similar triangles, right? So we talk about similar triangles, we talk about the Pythagoras Theorem. So we talk about Pythagoras Theorem, and then we're saying in every rectangle triangle, in dealing with every rectangle triangle, two things are mainly applicable. One is the Pythagoras Theorem, and two is the trigonometric ratio. So in a rectangle triangle, we're going to be using Pythagoras Theorem, and we're going to be using trigonometric ratios. So other form of triangles, we can use other kind of formulas and equations, such as the cosine rule, the sine rule. But specifically about right angle triangle, we'll be dealing with Pythagoras and Pythagoras theorem and the trigonometric ratios. All right. Right. So you must understand the concept of the right angle triangle, and then you also the terms in right angle triangle. We have three sides, which we name as the hypotenuse, the opposite, and the adjacent. In a right angle triangle, we talk about, for example, like this one we had here. So a rectangle triangle, we talk about this is a rectangle triangle. Why is it a rectangle triangle? Because one of the angle is 90 degrees. So we say this here is a right angle triangle. All right. So in a rectangle triangle, we talk about three sides here. First of all, we're saying this here, this longest side, the side facing your 90 degree is the hypotenuse. So your C is your hypotenuse side. And then this side, depending on your given angle, sometimes your angle can be given here, it can be given by B, or the angle can be given at A. So if the angle is given at B, then AC becomes our opposite. And then this last part becomes our adjacent. All right, so we're going to explain that as we go further. But we're saying in every right angle triangle, right angle triangle, we say we are two things we mainly make use of. We make use of Pythagoras theorem, and we make use of the trigonometric ratio. And the Pythagoras theorem says that what? Hypotenuse squared, C squared is equals to A squared plus B squared. Right. So I'm sure most have been dealing with this from the lower grade. That to find the hypotenuse is what? The sum of the other two sides. The hypotenuse is the sum of the other two sides. All right, and then to find either of the two sides, for example, if we need to find b now, b, the square of b will be c squared minus a squared. Okay, square of b equals to c squared minus a squared. And then square of a, if you need to find a, so a equals to the hypotenuse squared, that's the c squared minus a squared. All right, so that is right angle triangle. Okay, next. So next we're looking at the different names of the three sides of a rectangle triangle. You say in a rectangle triangle, for example, the one given below, right? So we're saying there are three sides, all right? So the side facing your angle 90 is your hypotenuse. It's always your hypotenuse. And we ever call an included angle. So in this case, our B is the included angle. So if B is our included angle, that means this side must be our opposite side opposite. And then this third side adjacent. Okay, so that we have what? Hypotenuse, opposite, and adjacent. All right, we have the hypotenuse, opposite, and the adjacent. All right. Okay, now if the included angle is given A, if A is your included angle, all right? If A is your included angle, that means this side here will be our opposite. It's the side that's opposite the included angle. So we call this one our opposite, and this always remains our hypotenuse. It's always the longest side, is the side facing the 90-degree angle. So this is the hypotenuse, there's the opposite, there's the opposite. Why? Because this is the included angle, and the third side is the adjacent. All right, so we can have an included angle either at this here, or we can have it up here. So, and that will determine our opposite side. All right, it is here, then it's the opposite, and then when it's here, and then there's our opposite. And lastly, this will be the adjacent. All right. Okay. Now, we need to talk about the trigonometric ratios now. We need to talk about the trigonometric ratios. So talking about the trigonometric ratios, we say we simply use the acronym SOHCAHTOA. We simply use the acronym SOHCAHTOA. All right, SOHCAHTOA, where sine is opposite over hypotenuse. Right, because we have three basic trigonometric ratios. In trigonometry, we talk about trigonometric ratios. So there are three trigonometric ratios. The three trigonometric ratios is the sine, the cosine, and the tangent. Again, there are three ratios. We have the sine, the cosine, and the tangent. So to understand what sine is, what the cosine is, and the tangent, so you think sine is opposite from the word SOHCAHTOA. Just learn the acronym SOHCAHTOA. Right? Just have the acronym. All right. So the sine, the X implies the sine, which means opposite over hypotenuse. By now we know what an opposite angle, opposite side is. The opposite side is the side facing your angle. Why the hypotenuse we talked about. So to find our trigonometric ratios, which are sine, cosine, and tan, we think sine is over hypotenuse, and our cosine, the C, implies cosine, which means adjacent over hypotenuse. So cosine usually have what? Cosine of an angle, sine of an angle, sine of an angle. All right. So when you say sine, it must be sine of a particular angle. For example, sine A, sine theta, sine beta, sine alpha. You understand? So it must always be the angle, the sine, the cosine, and the tangent. So whenever you talk about sine, it must refer to a particular angle. Sine of an angle, sine of theta, or sine of beta, as habit in mathematics. Okay. So saying sine basically is to find sine is what? Opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA. Please don't forget that. So, okay. So now we're saying, like here now, from this our triangle, our sine B. So our sine B, we have said is what? Opposite, which is what? AC over plus AB. So our sine B is equals to opposite over, that means what? AC over AB, right? And our cosine, our cos B, our cosine, that be by B, our cosine is adjacent over hypotenuse. So what's our adjacent? Adjacent is what? BC over hypotenuse. That's our cos B. And if we find our tan B is equals to opposite over adjacent, the tour. So tour, opposite over adjacent, so our tan B. Our opposite, which is what? AC, and our adjacent BC. All right. So as well, we can also check this other triangle here. So we can find our, now our angle is by A now. So we're going to refer to our A as our angle. So we can find sine A, cos A, and tan A. Sine A, cos A, and tan A. So sine A will be what? Opposite over hypotenuse. So sine A will be opposite over hypotenuse. That means BC over AB. Our cos A will be adjacent AC. So our adjacent is this. Why is it our adjacent? Because this is our opposite angle. It is side facing the included angle. So this adjacent. So to find our cos A will be adjacent AC over hypotenuse AB. And lastly, to find our tan A. Tan is what? Tour. Opposite over adjacent is tan. So to find tan A here, tan A will be opposite BC over adjacent AC. All right. Okay, so that is the concept of the trig ratio. So from there, we go to the next one. Go to this next slide. For example, in triangle, this means triangle. In triangle DEF, right? In triangle DEF, DE is 5, EF is 12. E angle E, this capital S stands for angle. So we say this angle E. So angle equals to 90 degrees. And then angle D is equals to beta. Angle D equals to beta. And angle F equals to theta. Angle F equals to theta. All right. Now, determine the length of the hypotenuse DF. Determine the length of the hypotenuse DF. You must find this length DF. So how do you find this length DF from here? So find length DF, because we have these two sides given, then we can simply use our Pythagoras theorem. All right, we can use our theorem of Pythagoras for our sine, to find our sine DF. So, and then because we are looking for hypotenuse, in this case, we're saying DF, our DF equals to, the square of the two sides. So basically DF equals to what? 5 squared plus what? 12 squared. So DF squared equals to 5 squared plus 12 squared. Okay, and that is Pythagoras theorem, that to find the hypotenuse is the sum of the square of the other two sides. Right, so 5 squared is 25, 12 squared is 144. So 25 plus 144 will give us 169. So 169, so to now find DF now, then we have to find the square root of 169, and that should give us 13. Okay, so our DF will be 13. All right, again, for our DF, we're saying DF is our hypotenuse, and to find our hypotenuse is the longest side, and to get it is the sum of the two short sides. So this one, and then the hypotenuse squared equals to the opposite squared plus the adjacent squared. All right, so we're saying DF squared equals to 5 squared plus 12 squared, and that'll give us 169. So this, to find our DF, DF, we find the square root of 169, and that'll be 13. So our DF is 13. All right. Now write the value of theta. Write down the value of sine theta, cos theta, and tan theta. how do you get the value of sine theta, cos theta, tan theta? Right, sine theta, what would be our sine theta here? So this is our theta here. This is our angle that's being referred to. This is our theta here. So if this is our angle, automatically this side be our opposite. Okay, because talking about sine theta now, so we're regarding this as our angle, and then this will be our opposite. Okay, because it's the side that is opposite to given included angle. So these are opposite. This is our adjacent, and then we said our DF will be 13. Right, our DF will be 13. Right, so we're gonna have 5 here, 12 here, 13 here. So now to now find our sine theta now, sine theta will be opposite. That is, we're saying sine theta is opposite over hypotenuse. So that'll be 5 over 13. That'll be our sine theta. Okay. So our sine theta basically is what? 5 over 13. And our cos theta will be adjacent. Adjacent is our cos theta again. Don't forget to say is what? SOHCAHTOA. Cos is adjacent hypotenuse. So it's adjacent 12, hypotenuse 13. Right. So our cos theta will be 12 over 13. All right. And then when our tan theta, tan is what? Opposite is TOA. Tan from our SOHCAHTOA acronym is TOA, which means opposite over adjacent. Which means opposite over adjacent. So our opposite here is what? 5. And our adjacent is what? 12. So our tan theta will be 5 over 12. Okay. Right. So now let's see how that is on the next slide. So we're saying to find our DF first, we need to use our Pythagoras Theorem to get, we're going to get 13 there, we're going to get 5 squared plus 12 squared, add together 169. Find the square root is 13, and then our tan theta will be 5 over 12. All right, and then the next question, on the next slide, on the next question B, write down, question C, write down the value of sine beta, cos beta, and tan beta. Sine beta, cos beta, and tan beta. So what is sine beta? Again, sine is opposite over hypotenuse. So now we define to this angle now. This is our angle beta now. So if this is beta, automatically here will be our opposite side. So our EF will be our opposite side, because now we're talking about this angle here. Okay, we're talking about this angle here. This will be our opposite side. So this will be our adjacent side, and this will be our hypotenuse. All right, so to find our sine beta, sine is from SOHCAHTOA. Sine is so, S-O-H. So which means opposite over hypotenuse. So opposite will be what? 12. And hypotenuse will be 13. So sine beta will be what? 12, 13. All right. And then cos beta, cos is adjacent over hypotenuse. So cos beta will be what? Adjacent 5 over hypotenuse 13. So our cos beta will be 5 over 13. All right. And then lastly, tan beta. Tan beta will be opposite over adjacent. Don't forget TOA. Opposite over adjacent is our tan beta. So what is our opposite here? 12. Is our opposite angle, opposite side to beta. So our opposite is, and our adjacent is 5. So our tan beta will be 12 over 5. Okay. Right. So let's look at other examples. All right. Right. Determine tan Q cos P here. In this example 2, determine tan Q and cos V. What will be tan Q and what is cos V? Right. How to find tan Q? How to find cos V? So tan Q will be equals to, first of all, we have 2 sides here. So the first thing to do is to first of all find the third side. Right? You need to find the third side to complete the 3 sides of the triangle. We have 9 here, we have 5 here. So you need to find tan Q. This is our Q here. You need to find, so that means this here is our angle here, right? So, but before we start, we need to find our PR first. So what will be our PR? which is the hypotenuse? 15. The hypotenuse is the one facing the 90-degree angle, 15. So we're saying, and then because we're talking about tan Q, PRB are opposite, and these are adjacent, right? Right. So to find this side here now, we're going to say PR because 2 squared minus 9 squared. So our PR was 15 squared minus 9 squared. So 15 squared is 225, and 9 squared is what? 81. All right. So PR squared is 15 squared minus 9 squared. That's our Pythagoras theorem. So use the Pythagoras theorem to complete the third side. So we say 15 squared, 9 squared. All right. So, and then we're going to have, so 15 squared minus 9 minus 5 squared, and that'll give us what? 144. We get 144. Okay. So then our P will now be 4, which will be what? 12. Okay. So we're going to have our PR as 12. Remember, PR as 12. So our PR is 12. Now from there, you can find our tan Q. Q will now be opposite. So opposite will now be what? 12, which is our PR, over adjacent 9. Remember, tan Q, tan means what? Opposite over adjacent. Over adjacent. Opposite being what? PR, which we said is what? Is what? 12. And then our adjacent, which is what? 9. Okay, so our tan Q will be what? Opposite 12 over 9. That'll be our tan Q. Okay, and then to find cos V now. In this case, we need to find cos V. We need to find our cos V. The same thing we're going to do, we need to use Pythagoras to complete the side. We need to use Pythagoras to complete the third side. So how do you complete that? We're going to say FV squared will be equals to, FV squared equals to 25 squared minus 7 squared. 25 squared minus 7 squared. Okay. So what is 25 squared? Get 625 minus what? 49. Okay. 25 squared minus 7 squared, that gives, so the square root of that will give out our SV. Okay. So you seem to find our SV will be 25 squared minus 7 squared. So, and that will give us 25 squared is 625. 7 squared is 49. So 625 minus 49, you get what? 576. And then to find out your SB, you find the square root of 576, and that will be 24. Okay, so S will be 24. So if our SB is 24, then cos V now, this is V, we're talking about VA now, then these are opposite. Hypotenuse is our adjacent. Remember, cos is what? Adjacent over hypotenuse. Cos is adjacent over hypotenuse. So our cos will now be what? Adjacent. Hypotenuse will be what? SB over what? Hypotenuse. Okay. And now our XB we said is what? Our SB we said is 24. It will be 24 over 25. So our SB will be 24 over 25. 24 as the adjacent, 25 as the hypotenuse. Give us our cos V. Hope you understand that. All right. Now, next example. Now, the same, state the following in terms of G, in terms of G, K, and M. State the following in terms of G, K, and Right. Now, what is sine K? What will be our sine K here? What will be our value of sine K? Yeah. What will be our value of our sine K? Right. Sine K will be what? Sine is what? Opposite over hypotenuse. So what will be our sine K in terms of this letter? State the following in terms of G, K, and M. You must state the values of this in terms of G, in terms of K and M. So what is sine K? All right. 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 So sine K will be equals to opposite. What the opposite angle? because you're talking about K, so that means this is K. Here's our K. So our positive what? Small letter K, the baby K, and then because this is our M, this side facing the M, this is our angle M. So the side facing M is the baby M. And this is our angle G. This is our angle G. The side facing the angle G is your baby G. All right, so this is how we label a right angle triangle. Again, your G, the angle, the side facing the angle will be the baby one. So here will be our baby G, and then this is our M, this is our baby M on this side, and this is our angle K, and this is our side K. All right, so now what is the value of sine K? Sine K equals to opposite. Remember, sine is opposite over hypotenuse. So sine K will be opposite. So what's the opposite here? It will be what? Small k over hypotenuse M. So our sine capital K, sine angle K, now this is our angle K. So sine of K be opposite over hypotenuse K over M. All right. So our cos K now, what will be the value of our cos K? What about cos K? Remember our SOHCAHTOA, adjacent over hypotenuse. Cos is adjacent over hypotenuse. So cos K will be what? Adjacent. With our adjacent, this being opposite, then our G will be our adjacent, because our M is always our hypotenuse, is the longest one. So M is the hypotenuse. M is the hypotenuse. Right. Right. Thank you. Yeah. So, right. Okay. Thanks for the comments. Please put up your comments. I can see your comments here. Thank you. And you answering. Right. All right. So now we think our sine K now. Our sine K will be opposite, small letter K over M. So K over M. Our cos K will be adjacent, which is G M. All right. And then number 3 now. What is the value of tan K in terms of G, K, and M? What value of tan K? So tan again is what? TOA. Opposite over adjacent. Remember your SOHCAHTOA, TOA. So tan K will be what? Opposite, small baby K over adjacent baby G. All right. So K over G is our tan. Right. Question 4 now. Determine sine G. Determine sine G. So sine G now, we're looking at this as our angle now. Sine G. So this is our angle. So because we're regarding this as an angle, automatically this is our opposite. So because this is our angle, then small baby G now be our opposite angle, the opposite side. And then this is our adjacent side, and M is always our hypotenuse. So what will be our sine G here now? What will be our sine G? So our sine G will be equals to opposite over M, the G over M. Thank you. We have G over M, that is a apocalypse bed. Thank you, apocalypse bed. All right. Okay, right. Our sine G be opposite M over hypotenuse M. Now cos G now. What about cos G? So cos G will be adjacent over hypotenuse. SOHCAHTOA. Cos is adjacent over hypotenuse. So adjacent is what? K. Because these are opposite. Because we're looking at what? G as our angle. So these are adjacent and the hypotenuse. So cos G will be K over M. Right? And then that's cos G. Then tan G. So it'll be our G. Tan is what? TOA. TOA means what? Opposite over adjacent. So opposite is G, adjacent is K. So tan G equals to G over K. Right. So tan G is small g, baby G over K. Right. So now look at this other one again. State the following in terms of P, R, and P, Q, and R. state the following in terms of PQ and R. So now what is sine theta? Theta in terms of PQ and R. What be our sine theta of PQ and R? So our sine theta will be equals to opposite, which is what? R over hypotenuse Q. All right, let's see. So our sine theta is from Aaron, K over M. Now we on the other one now. Okay, you have it as G over K, R over Q. So now look for cos sine theta will be opposite, which is R over Q. Okay, because this is our theta here. And then automatically this side is our opposite, this is our adjacent, this is our hypotenuse, this side facing the included angle. Right. So our sine theta then becomes what? R over Q. And our cos theta will be equals to adjacent over hypotenuse, adjacent being P, and hypotenuse over is what? Q. So you see what? P over Q. All right, so that's our cos theta. And tan theta, opposite over adjacent. Tan theta is opposite R, adjacent P. And then if you need to find sine alpha now, you have to find sine alpha. So sine alpha will be, we consider this as our angle now, right? We're considering this as our angle. So sine of this will be, so this here be considered as our opposite, this be considered as our adjacent, and this considered as our hypotenuse. So cos theta will be adjacent, which is what? Adjacent, which is adjacent, this being opposite, so adjacent is what? R. Because we consider alpha now, this is called alpha, sine alpha. So alpha, these are alpha here, these are opposite side, these are our adjacent side, these are hypotenuse side. So sine is opposite over adjacent. Opposite being what? P, hypotenuse being Q. So sine alpha be P over Q. All right. And then cos alpha be adjacent. Adjacent of, so adjacent is what? R over hypotenuse Q. And lastly, tan alpha is what? Opposite over adjacent. Tan alpha is opposite over adjacent. So opposite is what? P over adjacent R. Okay. So that is trigonometric ratios as we have learned today. So let's see the last slide. Okay. Now, the question now comes here now. Triangle DEF is shown with given dimension, right? Determine the length EF, write sin theta, cos theta, and tan theta. All right. So how do we do that? Triangle DEF is shown with a given dimension. This is a triangle, right? Determine the length of EF. So how do you find the length of EF? So find the length of EF, how do we do again? You say what? Our EF, we're going to find that using the theorem of Pythagoras. The theorem of Pythagoras. Right. So EF equals to 26. So somebody calculated this saying EF is 26. So thank you, that's so fast. So here is 26, fine. So now write down the value of sin theta, cos theta, and tan theta. So EF is 26, right? So what will be our sin theta now? So sin theta will now be opposite 10 over hypotenuse, 10 over 26, right? And then our cos theta will be adjacent over hypotenuse, our adjacent being 24 over 26. Adjacent is 24 because 10 is our opposite. So 24 over 26 is our cos theta. And lastly, our tan theta is what? Opposite over adjacent. So tan theta is opposite 10, adjacent 24. So tan theta is 10 over 24. Right. And then finally, Given these two here now, determine the value of sine n. Determine the value of sine n. So what is sine n here? So the same thing, the same process we're doing. So to find sine n, we need to complete the triangle first. Complete the third side, right? Complete the third side, and then after completing the third side, then you can now find your sine n. Okay, so to find your third side, you're going to say 17 squared minus 15 squared, and then you get the square root of your answer, right? You find the square root of your answer, and then you can be able to find your sine n. Okay, so, and lastly, on this other one, so we must find tan c. To find tan c, the same thing. This one I've got 5k. This one I've got 5k, and then this one is 4k. So with that, we're going to find the value of PO also in terms of k. Okay, we're going to find PO also in terms of k. So PO is going to be a value with k. And once we get the value with k, from there you can find our tan c. So our tan c, of course, is what? Opposite over adjacent. So because looking at tan c, so 5 squared, 5k squared will give you 25. So this are going to get 25k squared. This one will give you 16k squared. So we're going to say to find this small one, this PO, we're going to say 25k squared minus 16k squared. And that will give you 9k squared. All right. So and then you need to find the square root of 9k squared, and that will be 3k. Hope you understand. So our PO be 3k. All right. So now, and then to now find our tan c will be equals to opposite. This is our c now. Our opposite will be 3k over adjacent. And our adjacent in this case is what? 4. So our tan c will be 3k over 4k. And then if you simplify that, you can get 3 over 4, as it is, calculated by one of by B max. Okay. So, and then our tan c will be 3 over 4. So we're going to end the class for today. All right, we're going to end the class for today at this with this question. And next class we'll be looking at calculation using trigonometry. All right, how do we find angles? How do we, if we have an unknown, how do we use calculators? So please come around with your calculator for next class. So we see how we use calculators to find angles. How do we calculate angles and other calculations in trigonometry. So thank you for listening today, and enjoy the rest of your day. Any question? If there any question you want to ask? Bye-bye, sir, Apocalypse. Okay, thank you. Hello, ma'am.